Okay, so we're going to do some a task in integration between the two curves. So we're going to find the area between the two curves using integration. Okay, so first of all, there are two graphs. One is the quadratic, y equals fx equals x squared. The other is a linear, y equals gx equals mx plus c. Okay, so right now you see there are three areas in different colors. All right, and area 1 and area 3 is above the straight line and below the quadratic graph. But the pink one is just the opposite, is below the straight line but above the quadratic graph. So the context of this task is that you need to draw some lines with variable slopes. So that means the m in the equation of the straight line can be changed. And doing that is to make sure you have area 1 and 2, the sum of area 1 and 2 equals the area below the straight line, which is area 2, right? So how could you achieve that? So there are three tasks we need to do. The first one, you need to express c in terms of m. The second, we're going to use decimals to show how can we get these A1, A2, A3 with different m without using hand calculation, all right? And 3, we try to find the minimum value of area A2 by using Excel, all right? So we're going to do our task 1 in this video, all right? So in our task 1, you need to try to get c in terms of m. Okay, so where's the c and m? Okay, c is right here, m is there. So these are two parameters of the linear equations. Right, so let's have a close look on the graph. So you know, when the straight line cutting through the quadratic graph, there are two intersecting points we could call them alpha and beta as their x values. Okay, to find the three areas, we have learned that area 1 should be -2 to alpha because that's above the straight line and below the curve, and the curve is fx, straight line is gx, so use fx minus gx. That's for area 1. For area 2 is from alpha to beta, but since the gx is above the fx, so you are going to do alpha to beta, gx minus fx. Okay, and A3 is from beta to 4. Again, this time fx is above gx, so you see fx take over gx. Okay, so the condition for this task is like you must have area 1 plus area 3 equals area 2. So I'm going to do a little trick by bringing that A2 to the left hand side, and then you will have area 1 minus area 2 plus area 3. Okay, now let's see that's the time for us to write those integrals into the equation. So for area 1 is from -2 to alpha, okay, and we remember that's fx minus gx and dx, and then from, that's area 2. The area 2 is from alpha to beta, and you will have gx minus fx, that case, and you have beta to 4, and that's fx minus gx again. So all this equal to 0. Okay. But now you can see we could we could bring that minus sign. So we try to bring this minus sign into the integrand. You will see what? And okay, after this you will see like, okay, the first integral still the same. But if you bring that minus sign into the integral, it becomes plus, okay? And the things inside the integral sign will become like that. Okay, that's quite clear. So this is minus gx plus fx. So if I rewrite that a little bit, can I just rewrite this as, okay, fx minus gx? Okay, right now you see when we look at the upper limit and lower limit, okay, so minus 2, okay, to alpha, so you see they are the same. So the upper limit of the first integral equals the lower limit of the second integral. And that's beta, and here's the beta. They are the same as well. Alright, and the last one is 4. Can we combine all these three integrals into one? Yes, because you know they are upper limit of the first integral equals the lower limit of the second integral, and also your upper limit or your second integral equals the lower limit of the last integral, right? So let's combine them all together as one integral, like minus 2 to 4. Okay, so the good thing about this is you get rid of all these unknown alpha, beta, and you make the integral much easier. Okay, so right now let's don't forget what's fx. Fx just x squared. Let's go back to the function itself, two functions. Okay, the other one is just mx plus c, but since I might write this one more step. Okay, so we need to do the integration of this one. Okay, so the first integral should be s crib. The second integral is x squared for 2. The last integral is, might put c there. Okay, and the first integral is 64 to the power 3, 64. Okay, minus, that should be minus 8 over 3. Okay, 4 squared is 16 over 2 minus. So that's minus 2 bracket square, so that's 4 over 2. Okay, that's 4 minus, okay, minus 2 in that case. Okay. Oh, that's a C, sorry. I nearly missed that. Okay, remember what do you need to do now is try to express C in terms of M. Okay? The first one is 72. And a second one is, okay, the 12, the 6M. Okay, so that should be plus 6C. Okay, so 72, that's 24, minus 6M, minus 6C equals 0. So if you put 6C to the other side, it becomes 6C equals to 24 minus 6M. So if we divide 6 on both sides, okay, so you will have C equals 24 over 6 minus 6M over 6. So have 4 minus M. Okay, so that's how we get C equals 4 minus M. Okay, and so what's the implication of this one? So if you try to get straight line cutting through the curve and also get the area above the straight line equal to the area below, then that C must be related to M by 4 minus M. Okay, so you can say that Gx must equals Mx plus 4 minus M. Okay, so that's the end of the first video. So on next video I will show you how to use decimals to show the areas of A1, A2 and A3 with difference M. Okay, see you next time.